you are touching upon something that is very close to your heart at the moment, because this is very relevant to your new venture, Lucid Computing. Do you want to just tell basically what Lucid Computing is, and then I have 10 other threads to to pull
Yeah,
from
yeah,
that
yeah.
rant.
So essentially, essentially what Lucid Computing, what we're doing is that we are making it possible to track um, what compute hardware. So in order to train like an AI model, you need a bunch of like NVIDIA AI chips. And we build software to help you track where are all of those chips being located and what are they being used for. Because right now, a lot of these computer chips are being smuggled in places where they shouldn't be. Like we had the DeepSeek announcement recently out of China, and it was like a scientific breakthrough, but also most intelligence sources are telling us that they used a bunch of NVIDIA H100s they shouldn't have had that access to in the first place. So we're essentially building software that once you install this piece of software in the so-called trusted execution environment of the chip, we can actually figure out like where is the chip located and is it being used to train an AI model that sort of violates the United States like AI diffusion framework, because they have this like export control framework where they don't want certain countries to get access to this technology. So we make like the whole deal of export controls a lot more automated, because ultimately we want AI technology to exist in the world. It should exist in a safe and responsible way where it's not weaponized and where it's not used to create, rabies 2.0. So our technology is a way to sort of enable that, enable data center construction in everything from the UAE and Saudi Arabia and all sorts of places in Europe and the rest of the world, but that it's done in a way where we can sort of rest assured that we're not training super intelligence here, and we're not training anything beyond sort of the threshold of the export control in the United States government. And we know that the chips are not ending up in like any military hardware or application in a country where it's not supposed to be, essentially.
Right. To what extent can you differentiate between the use cases? Can you like detect if it's used for military things, or is it mainly if it's training or inference, or yeah,
No,
what
so
is the granularity?
we can't detect what it is being used for. So I mean, what we can detect is it used to sort of train a model above a certain compute threshold. So for instance, export controls are like 10 to the power of 26 flops. And the sort of idea here is that, if you have more compute because of this scaling loss that I talked about earlier, like if you throw more compute on the model, it will become smarter and more intelligent. And when it becomes more capable, you can also use it for all sorts of, weaponization. So it's essentially like you can detect if we're trying to train like something akin to super intelligence here, but we can also detect like who is doing the training more or less. So if you pair our technology with something like a chip registry, you can essentially say that okay,
Mm.
it's the chip is supposed to be located in this data center in let's say Sweden, for instance, but now it's in North Korea for some reason, and
Yeah.
that should probably not be the case.